Okay, so what type of engineer are you?
So I am a process and manufacturing engineer, which means that I help support product lines in the factory as they're being assembled and produced, and deal with issues that arise, and also come up with new ways to make things that make them better, faster, cheaper, more efficiently.
And what company do you work for?
I work for PerkinElmer. They're a biomedical device company.
How do the principles of science and mathematics apply to your everyday tasks?
They don't. So engineering is not always doing a lot of math, although sometimes it is. A lot of times it's figuring out how things work in very particular detail. So if, for instance, I need to make a part that has to be right to within 10,000ths of an inch, and it's off by 3,000ths of an inch. It's not just a matter of, oh, I've got to move it over a little bit. It gets very precise. But you do need a strong math background, especially with what I do, a physics background, to sort of understand conceptually how things are made and how things are built, and what effect different actions and processes are going to have on a product. Now there are other parts of engineering more on the design side, where you would have to do some more mathematical analysis, but I'm not a design engineer, I'm a manufacturing engineer, which is a little different.
How would you characterize an average day at your job?
Right now it's catching up with labor because the production manager sucks and didn't hire enough people.
Yeah.
But it's a lot of, what I do is a lot of troubleshooting. So I work in a high volume production line, which means we build thousands of these products a day. So a lot of what I do is making sure that not only are we building enough of these products a day, and we're building them right, and when something goes down, if say a machine breaks, and we have to figure out why a machine breaks, or maybe the machine didn't break, but it's not spitting out parts the way it's supposed to. I have to, figure out what's wrong with the machine, and it's not, oh, this thing broke again. It's, it's there. You have to do an investigation and figure out what happened, and after you figure out why it's not working, then you have to figure out the solution for how to fix it.
What is your favorite project that you have worked on as an engineer?
So I actually like the project that I'm working on now, which is basically the product that I work on. It's something called a microfluidic chip, and basically what it is it allows you to do certain biological and chemical tests much cheaper, faster, and more efficiently than the current standard procedure. This is kind of a sort of a state-of-the-art technology, so it's kind of cool because I'm not curing cancer, but I'm building the machines and the parts that cancer researchers are using in their research. So it's much more rewarding than some of the other products that I'm working on. I've also worked on missiles that blow people up, which so I like work. I feel like I'm actually doing something helpful to society right now. I like that.
Right. Makes sense. What tools do you use in your job?
So, because I work in manufacturing, I work with a lot of sort of production tools. So, for instance, I work with some dicing saws that can dice apart to within 1,000th of a millimeter. They can do it to that accuracy, which is actually one of the big challenges in engineering and production is precision. And basically, the more precise you are, the more expensive and the more difficult it is. So basically, I take these glass plates, and the machine, dices them up in little squares. When you say it like that, it doesn't sound very complicated, but when it has to be as accurate as it does, it actually is fairly complicated. And I work with a bunch of assembly machines, so machines that sort of automatically, put little drops of glue in place that, glue these chips to the caddies, and it's, basically a lot of machines that are for assembly and production. But that's particularly my job. Different engineers might be using tools to test or measure, some physical property or another. Some engineers only work with computers and code. So, it's different depending on what kind of engineering you do.
And how many other engineers do you work with?
Directly, 5, 6 if you want to count my boss, who I guess is an engineer, even though he manages engineers. And then, my company employs, tons of engineers, because, they're a technology company ultimately, and they need engineers to develop new technologies, and then also to do what I do and actually produce the products.
What makes your field different than others?
Other engineering fields or other
engineering fields.
Okay. So kind of like I was saying earlier, there's all different kinds of engineering. You can have electrical engineering where you design circuits basically, and if you've ever like opened up a piece of electronics and you see those circuit boards that are hugely insanely complicated and have all these different parts, there's an engineer that builds that. There's software engineers that design the code that that iPhone that you're recording me on runs, and all the software for that. There's mechanical design engineers who they would design, like for instance, they would actually design the casing for your phone or your laptop, or like all the parts in your car are done by a mechanical engineer. Civil engineers design buildings and structures typically. So there's all kinds of engineering, and what I do again is production engineering. So basically, a design engineer, they'll design this part, and that's all well and good. But now, you've got to figure out, okay, what's the recipe to build it, and then so that's kind of what I do. Is I don't design products. I design recipes and processes to build things, and then half of it's designing those processes, and the other half is troubleshooting it when things do go wrong. Because in the real world, things go wrong all the time when you're building stuff, and when you've got to build a lot of them, and you've got quotas to fill, you end up doing a lot of troubleshooting.
What are you doing, or what is your company doing to stay up to date with the latest technology?
So right now I'm working for a big company, and typically what most larger companies will do is they're constantly in a cycle of development and production. So you'll be producing one product, and in the meantime you've got another group of engineers who are designing the next product. Because one of the things they teach you about business is it's constantly sort of they teach you about a product life cycle where there's sort of a development phase where you're sinking a lot of money into it, but you're not selling anything because you're still developing it. And then as the product takes off, you start selling it and it gets popular and you're making a lot of money. And as time goes on, it becomes obsolete and it starts going to end of life. And if you're as a large company, if you only have one product, it is eventually going to go on that downward curve, and then your company's screwed if you don't have something else in the pipe. So what you're actually looking for is they sort of space their development projects out so that you have, when that sort of wave peaks, you've got a bunch in succession. So once one starts to tail off, you've got another one that's starting to peak, and that way you're constantly making money. Because at the end of the day, companies need to make money to survive. That's what they do.
Mm-hmm. And what engineering skills have you developed or improved upon during the past year?
So a lot of, again, process development, a lot of qualifying. So one of the things I did recently was I helped facilitate the move of a production line from Mountain View, California to Massachusetts, where I'm working now. And when you do that, a lot of products and manufacturing lines have a certain certification. It's called an ISO certification, and that certification basically announces to the rest of the business world that the company follows certain best practices for making stuff. So it's not just some haphazard cluster. Hey, we made it fine. You actually follow specific quality control processes. And a big part of that is basically qualifying all your machines and processes and making sure that they work like you say they're going to work. So when you move the factory over, now all right, so now I've got to not only install these machines and getting up and running, but actually prove that they are working exactly like they're supposed to. Because if they don't, then you make bad product, and that can be, especially in the medical field, that's a big problem if you're making bad products that aren't working like they're supposed to.
Yeah. And then finally, what made you want to become an engineer?
I was good at math, and it was good money. It's a good field to get into. It's hard work, and you got to bust your ass in school. But the economy sucks right now. Not that it sucked when I started college. And it's a good field to get into, and it's interesting. It's not, I'm not flipping burgers. I'm actually, when I go into work, and engaged in something that I've got to think about, and it's something new every day, and I'm not doing the same thing over and over again and getting bored. So it's challenging. And one of the things you'll find when you enter the working world is it's much, even though a challenging job is harder to do, obviously, than a job that isn't challenging. As time goes on, a challenging, boring job sucks. It's not fun. You do the same thing over and over again, and you don't want to get up and go to work in the morning because nothing changes and it's boring. So that's one of the cool things about engineering is usually you're always being presented with challenges, and it's why they pay you the big bucks.